Mit elektrischer Hauswärmetechnik können Bauherren und Sanierer Energie auf intelligente und effiziente Art nutzen. Ich möchte in meinem Vortrag einige Systeme und Geräte der elektrischen Hauswärmetechnik vorstellen.
Well, let me welcome you most cordially, ladies and gentlemen. And the next 30 minutes, I want to inform you about various electrical applications in the heat market and show you the varied options we have at the moment in that regard. I'm from the HEA. It is a market partnership of the energy business. We are the representative of the energy business, and therefore we are the ones most apt to tell you something about this topic because we represent the most various crafts which were integrated. We integrated the crafts, the energy companies, the suppliers of the electric power and the gas. We have the equipment industry and, of course, the wholesalers. Hence, through the instance of the umbrella organizations, we organize the entire value-adding chain, including electric installation and household equipment. Now, what are we doing? Well, we are the market partner for all. We design the cooperation amongst these various groups. We are represented in various standardization bodies like NF, heat, energy service legislation. We are in charge of the technical foundation within the scope of new energy undertakings, and we also do PR work for efficient application, focusing on power applications. Furthermore, we have undertaken 3 initiatives in which we are involved with companies from the most various industries, discussing various topics and subject matters like the initiative Electro Plus, dealing with future-oriented electric installation. Hence, electric installation, from our point of view, is the basic condition for intelligent building. Hence, the framework conditions for electric installation need to be given in order to then undertake the next step towards intelligent buildings. We have the initiative House Equipment Plus, dealing with all the characteristic features of efficient household technology, the equipment, but also the most various things around the equipment like washing powder, water consumption, and so on and so forth. Last but not least, the initiative Heat Plus, the initiative dedicated to household heat, ventilation, and air conditioning. Well, how come that power in the heat market is so attractive? Well, if we look back by 5 or 6 years, and if we consider the situation at the time, well, power in the heat market did have a relatively bad image still. This had various reasons. On the one hand, there were the emissions due to the most various types of production. And then, of course, it used to be the nuclear power, which also produced resentments against power. But the situation has changed in the past 4 or 5 years, also within the scope of the energy world. Even to a considerable extent, we move towards an electrical society, and in this context, power in the heat market is an interesting option. For example, to use excess power. So there are quite a few points speaking in favor of power from our point of view. Let me give you more details on that. Let's say that power is environmentally compatible. Now, how come we can say so? Well, basically, in recent years, there has been a development towards electric power as a form of renewable energy for power production. You see the shares of 15, then 32%, now 34% power production from renewable energies. And to the right-hand side, you see the minimum goals set within the scope of energy concepts, which are anchored down in European law, partially, and power production from renewable energy shall be taken up to 80% according to plans. Some people say we want 100% energy production from renewable energies, which is a long road to hoe still. But basically, as a matter of fact, electric power, at least in Germany, has the major portion in renewable energy already now. Power is intelligent. That is also an argument put forward. Well, it's put into inverted commas because energy is not intelligent, as a matter of fact. It has features of which you can say, well, you might ascribe a certain amount of intelligence to it, but of course you can control it very well. Power responds and reacts very quickly, and with electric power you can control entire crafts. And finally, there's energy which is apt for intelligent use, at least. Well, as of 2017, the rollout of smart media will happen, quite painstaking still, but the development cannot be stopped. We'll go into the direction of intelligent measuring system, and then there will also be bi-directional load shift of power out of and from the households. Electric power can be stored. The previous speaker showed a nice chart on smart homes with various loads presented within the scope of one's own production. This is quite a simple chart, but it indicates where the journey goes. During specific times of the day, there's a generation of solar power, even in our own buildings. And it can only be used in such a way that a major portion of that is pushed back into the power grid, and you are paid for it, more or less, and the rest is consumed in the building itself. Going one step further, and there are some systems, management systems, storage systems, by means of which the portion of which is fed into the grid will be shifted. And to the right-hand side, you can see that it's pushed into times during which up to now we have used power from the grid. This is quite idealized. The chart by the previous speaker was much more detailed. But this is the case as a matter of principle. Of course, there will never be 100% coverage. At least I don't see it at the moment. But there is, of course, use of our energy to the tune of 80–90%, which is also a matter of cost incurred, of course. But that's not the problem for a start. Well, electric power is safe. When the energy transition was announced 4 or 5 years ago, there was the suspicion that there would be a major breakdown, that there would be many power losses. But here's a chart from 2015, which I've selected, and you can see that this is not true. In Germany, still, as a matter of fact, we have very few times when there's no energy supply. I don't know when we reach 80%, then many things still need to be done, also regarding the enhancement of the grid. But the electric power as it is produced and consumed at the moment is safe. Well, Canada has long times of standstill, and this surprised me quite a bit. Long times of failure, but I rely on the figures nevertheless. Well, let me now present some technologies which are interesting from our point of view because they're energy-based. Let's start with the heating systems. On the one hand, the classical heating pump, and there's power-producing heating, mini BAKW, and well, this is kind of a combination working with natural gas and producing power. Then we have a hot water system with a heat pump. And these are systems which are future-oriented for sure in the heating market. Now, how come? Well, let's take the example of the heat pump. It has a big advantage. It is using the environmental, the ambient heat in a dual fashion. It uses the heat stored in the earth or in the air, and it can also use renewable energy for the operation of the heat pump to be guaranteed. We have the 3-to-1 rule for the heat pump, producing energy with one part, that is power for the operation of the heat pump, and you produce 3 parts of ambient energy, and then you get 100% heat energy. And if you want to contribute 25% from renewable energy, and if you agree on an eco-based tariff with your supplier, then you get an eco-based system, which is fully fledged. If you do this in a sustainable way, this can be an instrument to reach the climate-oriented goals and contribute to CO2 emission avoidance on a national and European level. On top of that, the heat pump can do much more. It can support load management through its function with a smart grid ready label. It can also use excess power in times when the demand is low, hence it's a multi-talent. And the operating costs are relatively low as compared to fossil heating systems. But to be fair, the procurement costs are a little bit higher. And at the end of the day, this will be balanced out. That's the principle. Basically, we use air, geo and hydro energy from groundwater, from deep drilling, and from air. And we drive energy, and then we use it for the heating of buildings. As you can see here, there's the source, and then there's the drive energy, which is also renewable. Part 2 of our technology. This takes us to the nitty-gritties, like electronic flow heaters, equipment which is apt for cases in which heating and the hot water supply shall be separated, which is advantageous in there. And there's home ventilation and recirculation, recovery, relatively new energy, which is not yet that well known. And we have underfloor heating. The flow heaters and home ventilation shall be presented in further detail, also presenting the advantages and effects of a central hot water supply. Now, hot water supply with decentral equipment, how come that it's so interesting? Well, basically, since we heat the water directly at the tap, we don't have circulation losses or distribution losses. We don't have to take the water from the basement to the first or second stories. It can be produced in the vicinity of the tap, and we don't need supporting energy for circulation pumps. Since the water is directly heated at the tap, near to the tap, there is a very low Legionella-based risk. And if you don't have Legionella-based risk, you need not take samples, especially in rental buildings. And the maintenance intensity is low because the equipment is quite reliable. Well, there are smart technologies and functions we can use with these devices. By means of touchpad, app, or remote control, we can adjust the temperature. We can read out individual data. The duration of use, energy and water consumption can be read out directly, just like the costs incurred. And with this information, we can change the user behavior. independent of whether these are central devices or not. Such reading out and retrieving of data and facts is useful for the user behavior, no matter which heating system. Now, home ventilation, here you see the system, which is a central one. It works on the basis of the principle that you use a central ventilation device from rooms from which you want to discharge air, like in bathrooms or kitchens. You discharge the air, you lead it through a central device, and you would transmit the heat of the discharged air to air supply, and the supply air is reintroduced into the rooms of the home. What's the advantages of this? Well, especially in new buildings, the buildings need to be airtight according to the legal provisions. Due to that, a lot of humidity remains in the rooms because it cannot be discharged. There's no untightness because of windows and other things. There's humidities amounting to 10 liters a day. This is produced in the form of water by a three-members family. And therefore, from our point of view, it is highly interesting in such buildings to build in such ventilation systems. Energy efficiency is guaranteed by means of heat recovery. The degree of heat recovery is relatively high. Even in passive houses, it's standard. And, well, this is a matter of efficiency also in the NEV requirements, because with such systems you can fulfill specific requirements, and you can realize the ventilation concepts in such buildings, checking whether such ventilation makes sense and is needed. Here are some pieces of information. How come that it's so important? Well, from our point of view, air is needed for life. We are surrounded by air, and we depend on the quality of air. And thus, this speaks in favor of a home ventilation system, filtering the air, also considering the air entering the building. Sometimes people have pollen allergies. There are fine dust burdens in the environment. And the other way around, this means that the air coming in from outside is filtered just as well as the air which is passed back from the interior to the outside. So that's a good thing as a matter of principle. And, well, we also put it on our agenda, and we are optimistic that those systems will make their way even more strongly, not only in the new buildings, but in the stock of buildings too. Now, storage heatings, well, basically in the 60s and 70s of the 19th century, they were a big issue. Those storage-type heatings were used at the time to balance out lows in the load, because there was a lot of energy consumption during the day, but low demand during the night. And, well, we tried to use the power for balanced load profile. The devices were always under discussion. There was a discussion about asbestos for some time. Then, in terms of control, some of the devices were bad. They were relatively large and rigid equipment. Then, the past 10, 15 years, these devices were used less and less. Large housing companies are having such equipment in their stock. But now, maybe 1 million heating systems are used based on the storage basis. Of course, there's the new aspect to it now. Basically, there's excess power in abundance, which we try and use in a meaningful way. Hence, these devices in the old form and also in a more modern form will become an option once again in the long run. Hence, we have excessive power from wind, from solar thermal industry, from photovoltaic stations, and we don't have real use for it. Hence, this would become an option for the future to reuse these devices on a modern basis. To keep these devices on the market and finding new potentials for it. Such a system looks like this. Also pilot projects from some energy companies and industrial companies who have a supply of eco-based power, and then we go directly into the heating to the central. Hence, this is a perfect kind of control. And it's one option to store excessive power. Of course, the heat pump is still another option, but we shouldn't lose this out of sight completely. Now, what about such a modern building operated with power-based systems? Well, let me show you the principle of this. Of course, this is highly simplified. If you want to develop a fully fledged structure for it, it becomes much more complicated. Hence, we start from a building. It's well insulated, as I assume. Then you should use a heat pump, as we would suggest. There is a circuit distributor. There's power supply. Then there's the use of ambient heat, either from the air or from the ground, from the earth. Ideally, since it's low temperature system, this will be combined with water-operated underfloor heating. That would be the first component. Then, furthermore, we would put a photovoltaic system on the roof, which is also interesting. But what does that have to do with a heat pump? Well, nothing for a start. But to combine this, you need an energy management system. Let's assume that the energy management system also has storage facilities. Hence, this would provide the link from the heat pump to the photovoltaic system. There are studies by companies saying that about 50% of the power they generate themselves could be used for the heat pump. Well, then let's say we separate the heating from hot water supply and we build in electronic flow heaters. Now, for the times of transition, to disconsider the heating, would have electrical underfloor heating temperature facilities, for example, in the bathroom. Heatings which are fully electrical, and they move up relatively quickly, and they can be used in times like October, November for 2-3 hours. You just switch them on to produce a cozy temperature without burdening the central heating during that time. Then there's a home ventilation system, here a decentral one. This is also available with heat recovery as an alternative, an integral device, a ventilation device with heat pump in combination as a central system. That's also available. Then you get the link to the smart home. And, well, basically, there would also be individual room control, a link via an app, and then you could operate this from outside. You could readjust the temperature. Or if you are in Frankfurt and if you had to drive over a distance of 2 hours, you could already adjust the temperature in your home. You would say, I want 20 degrees when I reach, and that's it. No problem. And such combinations would be the next steps. Now, what is still missing? Well, the last option, integrating an electric vehicle. Hence, you now get a fully electrical home in considering all the crafts, and the electric vehicle, once it has the necessary battery technology, could also be used for load shifts. At the moment, this is not yet really possible, but in 10, 15 years to come, this will be the case. Then you could use the electric vehicle as a storage facility, and in times during which you don't need the vehicle and there's demand for power, you could take the power from the vehicle in combination with a photovoltaic system, hence a fully closed loop in the system. And this is the simplified version of what it would look like, and that's our option for the future. Of course, many things still need to be upgraded, many things are being tested, many things have already grown fond. Of course, there are links which are still missing here and there, but I think we are on the way to such a future. Recalling the graph from the beginning, starting from 80% power generation based on renewable energies, this is certainly an option which will certainly come, at least from my point of view. Electric devices, considering the efficiency categories for hot water boilers and hot water preparation, well, we are in the best areas in all labeling categories. In heat pumps and flow heaters, we are in the best label classes. As a matter of fact, in hot water A is the best class. In boilers, A++. While A is the best label class for hot water, therefore it's marked in green. At the BTW with a heating cost comparison, and as a matter of fact, if you consider the total cost for a year, you can do decentral drinking water production, you can use the waste heat and all the other sources of energy. Well, this is really cost effective. If you see the valuation here, this is even competitive, to put it in cautious terms. Right, and now my conclusion. From our point of view, the importance of electric energy is growing in the heating market, clearly. As a matter of fact, extensions are taking place on a daily note, hence new renewable plants are added to the list on a daily note. Hence, power becomes more and more ecological from one day to the next. You have the option to choose from anyone, be it eco-power, what have you. You're free in your choice. And of course, power, on top of that, contributes to solving problems in the heating market, and it also supports the power-based systems in sum total, power in the heating market, and it contributes to climate protection very clearly. Right. Here, an impression of what we are doing. We also did a brochure, and in the next 2 days, this will be put in the network, describing the advantages I've just illustrated. It helps for argumentation's sake, and all the advantages are presented. Of course, you can also consult our site. I presented our initiative at the beginning, and you can also discuss with us. We are moving around in Facebook. We have 12,000 friends, and we also go into discussions on topics like power in the heating market.